So yeah, today we'll talk about a bunch of stuff about GraphQL, obviously, and about like a bunch of things that will give you an option to use GraphQL even today, like get started pretty fast. And yeah, so a bit about myself. My name is Vladimir Novick. I'm software architect, consultant, Google developer expert, author, and on a daily basis, I do a bunch of stuff in all of these fields here. If you feel like you want to follow me on Twitter, you have my Twitter handle and my website. So I want to relate like to what is GraphQL. We had about GraphQL trend going over time. There is huge interest over there for last like 5 years. Well, obviously nowadays the interest is more into like all the what's going on, but GraphQL is adopted by lots of companies out there. So among them, like really big ones, and you can go later on through the slides and look at the companies that you probably know. There is Facebook here. You probably know Facebook, right? And a bunch of others. If you try to search what GraphQL is, or if you search or was wondering what GraphQL is, you will see that the fundamental statement on the GraphQL.org is that it's a query language for your API. And in a way, we are told it's sort of like a magic, right? But the question is, we don't like magic. We want to understand what it is, right? And before understanding what GraphQL is, I want to talk about what's wrong with REST. And I'm not talking about this kind of REST. I'm talking about the RESTful API. Now, we all use RESTful API for quite a long time, and the main idea is to have a request, like bunch of endpoints, we trigger this request, we get the data, right? And the core idea is to have a URL for every resource, which is fundamentally a good idea, right? But the implementation is not so much. Now, we have different mechanisms to kind of work around that. We have like caching mechanism. We have we need still to consolidate a bunch of things on the client, and we've already used to live with that, right? But what if there is a better solution? Now, RESTful API has some problems, and these problems is in one of the like major like statement of the RESTful API that resource is coupled to implementation. Apart from that, overfetching is a commonly spotted problem. And the idea is when you get a request for a certain page and you need to display, let's say you have a blog CMS and you display a list of posts and you just need to display a username. And from your endpoint, you just get the huge huge data object of all your user data, which is too much, right? When we're working on the web, that's fine, but whenever we go into mobile realm, when the network traffic is important, maybe like for low-end devices and so on, and different data plans, that's important part. We don't want to send too much data over the wire. And there is also the underfetching. When, let's say in the same example of blog CMS, we have a list of posts, and every post will return an ID of the user, right? Now, let's say we have 100 of posts on the page and 100 IDs for the user. Now, then we have a different endpoint for the user that has more data. It means that we'll chain requests to the server and have back and forth going on of like network traffic and so on. And the best example of the worst API is Star Wars API, not because I don't like Star Wars, I'm a big fan of Star Wars, but because if you look at the API structure, you will see that it has the data for the person, and it has an array of films, and every item in the array is another endpoint. Which we can argue that, and I wouldn't argue on that. I agree that it's bad API design, but it means that in order to get, let's say, all films and species and vehicles and do like intersection between them, I just need to get a lot of requests to the server and consolidate everything on the client. right? Which is also, it can be broken pretty easily on the client. So GraphQL, and that's how it looks like. You have the users and a bunch of posts for the users and so on. And the question is, how does GraphQL solve it? It avoids overfetching. It prevents multiple API calls. It also has lesser communication with API developers, because imagine that you develop a new page and you need more data on this page, so probably you will get more, you will ask for another endpoint, or you will reuse the existing one. Now, if you will reuse the existing one, there's a good chance you will hit overfetching and underfetching problem. And probably you will ask for a different endpoint to serve the data that you actually need, and then you'll get too many endpoints, and it will be more interaction with, like, please give me endpoint, refactoring, and so on. So in terms of like team management as well, it's and like velocity of the team, it's also important. Now the cool part about GraphQL, it's also self-documenting, and you will see why in a bit. Now GraphQL says the following thing: you have just one endpoint. Just one endpoint with post request, and you send the data. Now the cool part, and you send like in specific form, in specific query language that will I will walk you through this like domain specific language. The main thing of GraphQL, that on the client I define what data I want to get, and the server will return the exact shape of data that I requested. So I know that something that I requested, I will get exactly the same. There won't be undefined, there won't be nulls, there won't be like non-existing keys and so on, because it simply cannot happen using GraphQL. Now, another thing I want to point out, initially I told that GraphQL is a query language for API, but now I would say that this statement is sort of wrong, because when you read this statement, it's a query language for API, the first thought, at least like some people say, the first thought is that you need to have your API to have GraphQL, right? And it's wrong, because GraphQL is a spec of how you can communicate between the front end and the back end, and how you can resolve the data back to the client. So how does it look like? It looks like this, and you see sort of like weird syntax which looks like JSON, but it's not. It's also in some form of like ID, web ID of sorts. Now, the cool part with GraphQL API, every GraphQL API will expose, unless you limit that on the server, will expose web ID that will be sort of like a postman, that you'll be able to query the data from this endpoint. And here, for example, I ask for all films. I ask for films under all films and the title. And as you can see, the shape of the data will be exactly the same that I asked. Now, if I will ask, like I wouldn't get like a name here, or I wouldn't get an empty object, because it's simply not possible. The request will fail if I will try to return that from the server. And this is a simple example. And how the request looks like. I basically send a post request with a query variable. Inside query variable, I have inside the body, I have the stringified syntax that you've just seen here. And the server knows how to parse the syntax and resolve the data based on whatever is provided. Now, in our case, here, I say that user ID should be 1, and that's what I get, even though like there are multiple users. So it's like a query parameter, right? Now, this is a more complex example of GraphQL, which has way more features than just querying. It has variables. It has like reusable blocks that are called fragments. It has specific input types. It even has directives that enables simple like if statements inside this query. Now, if you look at this query, we're trying to get all planets And the planet with the name and diameter, rotation period, residents, bunch of residents with species and vehicles, and the list goes on. Now, if you look into Star Wars API and imagine each one of these things was an API endpoint, like REST API endpoint that you need to call and get the data, consolidate everything on the client. So imagine how it's useful on the front end to just say, give me all this, and you get the data. So yeah, and it looks like this. This is like web IDE called Graphical. So yeah, the question is, does GraphQL have the equivalent of LeftRight Join? If subfield doesn't exist, existing fields will still be returned. We will see later on how it's implemented on the server. So basically on the server, you'll be able to do things you're familiar with. You want to resolve data from using SQL, like you can do that. You can resolve data from microservice, you can do that. So yeah, I will also relate to that later on. Now, the cool part about GraphQL that whenever API is exposed, you can see the docs of everything that is available. Of course, it's subject to your permission. Like you can limit that. You can say, okay, only parts of this schema will be available. Now, this schema doesn't represent the database. This schema represents only whatever I defined on my server following GraphQL spec. So GraphQL has three major operations. You can do queries. And the thing that we just seen, this is a query. Queries are used to fetch the data from GraphQL endpoint. There are also mutations. Mutations are for modifying the data or running a side effect. So it's not necessarily has to be insert or update or delete. It can be just running, notifying some third-party servers that something has happened. And the cool part with GraphQL, you can combine different data sources, or not even data source, maybe like REST endpoints, into one spec that will be available in one endpoint to the client. Also, GraphQL has subscription operation, which means that you can subscribe to real-time updates through the WebSockets. And here we bring you basically real-time capabilities to our apps in the same, like following the same spec. Now, queries look pretty much like this. We already seen in the graphical idea how it looks like, and I can name them. I can get planets with all planets and so on. And I can provide arguments. So I can say first planet is 1 and so on. Now, all these arguments you define on the server. So it's not that it's limited to some set of arguments. It's up to you, whatever you define on the server. You can use aliases in queries on the front-end side. You can say, okay, my query is named post, but I want the data to be returned and named as a first post. So you can use aliases. You also can use variables, especially with mutations. This is important because you want to, let's say in this use case, delete a post with a specific ID. So you need to provide this ID somehow. Now, in that case, in the post request to the endpoint, you will see in the body, you will see two variables. One will be the query with stringified mutation, and the other will be the variable with the actual post ID. On the server, it will know to inject the variable inside the query and run so-called resolver. Mutations used to modify the data or running side effect, and subscriptions subscribe to real-time updates. Now, what about the server, right? How we define this on the server? Now, the main point of GraphQL spec is you define a schema and you define types on the server. And whenever, like I say that, then you probably can understand why the data is predictable, or it's predictable on the client. Because whenever I have a type system on the server, I know the specific type will be resolved, and it cannot be something other than that. So I know if my query will return type of post, I know for sure there will be a title, content, and a user. So it's a type system. And here we define an object type. GraphQL object type. There are different types. These are called fields. We have scalar types. Scalar types, the existing ones are integer, float, string, boolean, and ID for unique identifiers. And you can define your own scalar types. In lots of GraphQL implementations, you have date as another scalar type because it's like a common use. You will probably have some sort of timestamp. You also have these exclamation marks, which will mean if the user has to be there or not. If you don't provide this exclamation mark, then it means that post can have title, content, and not necessarily need to have the user. So it's up to you to define how strict your API is. Now, here you see that user is another type that I also defined. So it means that my post will basically be resolved whenever I get to the resolution of the user. It will resolve this type and so on. And we can also have array types, obviously. To get more into like the schema definition language, you can go to GraphQL.org, learn a schema. There are lots of more about that that we cannot cover in this talk. In fact, on my YouTube channel, I have 10 hours bootcamp on just that. So you can, I will share a link later on. You can follow me on Twitter and you will see like this bootcamp as well. So the cool part about schema definition language, you can define that user points to a user and it points to do's which point to user. So you have a sense of like a graph basically, right? The thing is, because implementation is up to you, you need to be careful about not getting to like circular dependencies or some other problems that can occur. But since the implementation is up to you, how to resolve these types, you can do literally anything with that. Now, speaking of resolution of the data, there is a concept called GraphQL Resolvers. Resolver means that whenever I have a type of user, I will resolve the data from specific either endpoint or data source or whatsoever. And it will look like something like that. We have a query resolver, which means all the queries that I can remember the query thing I explained earlier. So in this case, I can run a query called human, and I can pass different the resolver will get different parameters, and I can return data from my database. And just depends on your implementation. Can instantiate like new human instance, whatever server implementation you use. In this case, is JavaScript. We can use other solutions, other languages. The main idea that resolver is a function that resolves data for GraphQL type with compliance to schema. So if I have a resolver here and my human query is defined in schema definition language as something that that returns type human, if I return something else, I will get an error. My server won't work, right? And there is also another more information on resolvers and how they work. So speaking of server implementation, there are a bunch of them. So it's like C#, Clojure, Elixir, Erlang. So you can see there are like literally lots of them. And in different languages, there are different explanations, how different libraries, how you can use GraphQL. Because basically what you get in these libraries, you get a way to define your schema, and you get the way to kind of pass the data from the whenever it gets to the server, pass it through the schema and verify that schema it's compliant to the schema basically. So if you write your own server and have your really like simple example in Node, I use a library called Apollo Server, and I have really naive implementation here, like no database, just a global variable with posts and users. And I can simply define type definition by using JQL library and define something that we already seen, right? These GraphQL types. Now, what it means that I can query my posts and I will get an array of type post. And I can query users, I will get an array of type users. And it goes on. Now, the resolvers will be just a function that will get the data from my users variable and will return back to the client, right? And in the end, I run my server. It served the server on specific port. I don't remember the default port, and everything worked. Like, you need to hook things up on the client. Now on the client, in this example, I use React. You can use any library that you like. You can use Angular, Vue, Svelte, vanilla JavaScript, and so on. There is a library called Apollo, the whole project called Apollo, and it gives you a bunch of things on top of just sending the post request and with like stringified query. It gives you the caching mechanism. It gives you lots of tooling, like as a layer on top of all the like GraphQL communication. And specifically with Apollo, it also gives you the it basically gives you also the subscriptions and WebSockets configuration that you can define. So you don't need to use something like Socket.io or other WebSockets implementation on the client. You can use Apollo with additional libraries and you're good to go. They have implementation for React, for Angular, for Vue, I think for Svelte as well, for vanilla JavaScript, so whatever you like. So for if you're familiar with React, I use a feature called React Hooks here, and basically create a query that will return different types of states, loading, data, and error. Whenever the result gets to the client, I basically get all the data inside the data variable. And here are the example of using a mutation and passing variables with different options. So what about architecture, right? So we have GraphQL endpoint, right? But what about how do you migrate, right? Or like how do you experiment with that? So you have database that is connected to you resolve things from the database, but you can also connect these to legacy systems, microservices, third-party API, and have everything in one like typed system that you can also like separate to different like modules and like stitch them together and so on. And eventually, what you expose to the client is documented endpoint with, and you don't really need to worry about versioning. You don't really need to worry about caching. If you want to do caching, there is a possibility. It's possible to do caching for that as well. It's called persistent queries. But yeah, that's how it looks like. And speaking of architecture, I want to talk about something like three-factor app architecture. And this is just microservices architecture, just the basic one. We have an app API layer, communicates with the database, and bunch of microservices. Now, recently there is a proposed architecture called three-factor app, which means that we have solved a real-time GraphQL. By saying real-time, I mean we have GraphQL subscriptions that propagate changes to my client app. Now, I can write the state inside database. Whatever I write or update in database, I can have an eventing system that will trigger different webhooks or different serverless functions, will do different processing asynchronously, and will write things inside the state. Now, if I have some sort of layer that can read this database and basically resolve everything through WebSockets to the client, then basically I have asynchronous processing here, non-blocking things, and this is something that lots of businesses are adopting recently. And the question is, how do you start with this kind of backend? Like, how you do that, right? So you can code your own. You can use two different services that work on the GraphQL API layer. is Asura, and in this architecture is Asura and AWS AppSync. And on the database layer, we will see today how to use Yugabyte with Asura as well. Because as Jimmy mentioned, Yugabyte provides you, it's PostgreSQL compliant, and because it's PostgreSQL compliant, we can use Asura Engine on top of that. So what is Asura Engine? And today we're talking about lots of open source stuff. So Asura is also an open source and free engine that gives you and auto-generates basically real-time GraphQL on top of new or existing Postgres, which means you don't need to write your resolvers. You just get the CRUD out of the box, right? And it can be deployed to any cloud. It can be run locally. It's compatible with auth. It can run on top of new existing Postgres. It supports different add-ons, PostGIS, TimescaleDB, auto-generates GraphQL API. Now, this part is kind of cool. It's basically, the engine is a compiler. It compiles everything to performance SQL statements using Postgres features. So instead of having different resolvers running, different SQL statements running for every type in your GraphQL schema, it will actually compile everything. I'll understand your the flow that you need to get to, and will perform a SQL statement. Now, if you don't use engines such as Asura, for instance, you can get a problem of n+1 problem. Whenever you want to run a query and resolve n amount of types in the query, plus the query itself, so you get n+1 SQL statements on top of database. This can be also prevented by using different packages such as data loader and others. There are solutions for that, but with Asura, you just don't have it. You just don't have this problem. And it also comes with Asura CLI with awesome tools like migrations. And in fact, I recently wrote a blog post on blog.Yugabyte, so you can check it out about how to use Yugabyte with Asura. We'll also see it today, actually. It can work with custom SQL statements. It has configurable access controls for the data, can be connected to your GraphQL server, and has a venting system. And in fact, let's just see it in action, right? To see it in action, I will use we'll download the Docker Compose, and in fact, I already downloaded that. So I would probably just do Docker Compose up. And what it will do, it will run the GraphQL engine, and it will run the Postgres in my Docker container. Now, what I can do, I can go to localhost 8080, and I will get inside Asura console. Now, Asura console will provide me with different tooling, and one of these is the IDE that you already seen, with no things here whatsoever, and a tool called Explorer and so on. Now, it has the data tabs, which is sort of similar, the idea to pgadmin. I can create tables on database, and let's in fact create post table with type unique identifier. I will generate this unique identifier, so I have also a bunch of helpers. My post will have a title, and it will have content type text as well. The primary key will be an ID, and let's also add user ID, because we want to connect it to users as well. And my user ID will also be a unique identifier. So my user ID, whenever I create a user table, will be a foreign key to users table. So I create this table, and the cool part is, if I go to Graphical, I already can see that I have queries, and I have mutations, and I have subscriptions. And it's not only that, queries that I have has all these things here. I can run limit them. I can run where clauses in GraphQL. I can order things. And if I'm not familiar with GraphQL syntax, or I'm just starting out, I can go to Explorer feature here and just click on things that I want to create, and it will work. But before we create a post, let's actually create users tables as well. Unique identifier. We also generate this unique identifier. have a name, and the primary key will be ID as well. We make it really simple for this example. Now I need to add a foreign key, so I would add it here. A foreign key reference to database user ID will map to ID. Now everything that I do here using Asura CLI will be written as migration files that you can run in CI to update your apply these migrations on your production database. All of these configurations, like foreign key, obviously it's in database, but all the other configurations that you will see today are also stored in the database. So everything can be applied through migrations. So right now, I would expect that I will also see users. And indeed, I have users here. And in fact, what I would also expect, if I query posts, and I want to get the title, I want to get the content, and I want to get a user, I would expect to get a username. But in our case, I don't get it, right? So the reason for that is because Asura can work on existing Postgres as well, and you don't really want to have all foreign keys mapped to like GraphQL Resolvers. So you have this ability here to go inside relationships and add a user as a relationship, which will actually give you an ability to use it inside GraphQL query. Now let's see an example of adding a post with title, let's say my title, okay, it's query, sorry. Let's write a mutation, and it will be insert post and objects. And again, I can have an explorer here. I want to insert post. The post will have title. Title will have will be first post, and I will have a content, some content, and I will also insert a user and username, right? And I want to return the affected rows. Now, if I run that, I will see 2 affected rows. If I go to my data tab, I will see posts and I will see users, right? So everything, you see, like in a couple of minutes, I already have GraphQL API with even subscriptions. I can even subscribe to changes and get real-time updates here. Now, you can say, okay, fine, you get the CRUD, it's sort of a magic, but what about custom logic, right? Like I want to have the power to change things, right? So first of all, you can always write your own SQL here, and it will be basically, if you create a view, let's say, create a view users1 as from users and run that, I will see users1 view created. And in fact, if I go here, I will see users1 as well. So I can create custom views, and whenever I create a function here, SQL function, I will see mutations auto-generated for that. But if, let's say, I have different server with GraphQL resolvers defined, GraphQL schema defined, I can go to remote schemas and add this server here, and it will basically stitch the schemas, 2 schemas together. So I can do synchronous business logic in that sense. And remember the eventing system I told you about? So I can go to events and add an event trigger and say whenever the name will be echo, and let's say whenever a post insert happens, trigger some URL. And let's create this event trigger. Obviously, it will fail, but if we run that and get into our events, we will see that event ran and it sent all the data that I need to the server, potentially serverless function that will do anything that you want and can update the database. Now, to update the database, it can use the same endpoint. You don't need to have connection to Postgres. You can just have the same endpoint. Now, this is kind of cool, right? But what about, so there are like also in the slides, bunch of explanations what everything is about. I will just go fast through that because I already showed you. So Graphical Tab is, you can set headers, you can execute queries, mutations, you can analyze queries. speaking of that, if you go and inside history, you can click on Analyze, and you will see the SQL statement that is executed. Now, Data tab will give you a bunch of stuff. In addition to that, in addition to just having the data view of the database, you can also set various granular permissions. You can actually go and set a user role. You can say, okay, I want to get to see only posts when user ID is equal to something that is passed from JWT token as an environment variable, and limit that just to the title. So this user will be able to see only the title of his own posts. So you can go really granular there. So this is the data tab. Remote schemas is stitching schemas together, and the event triggers is connect to custom webhooks and so on. Now, authentication, you can use webhooks, you can use JWT. Now, you can also run Asura locally on top of existing Postgres. And in fact, what we will do now, we will run Yugabyte with Asura on top of existing database that I have here. Now, to go to Yugabyte UI, I have a cluster set up and running. And I have here a Yugabyte cluster with a replication factor of 3 and 3 nodes. Basically, I have 3 TS servers running. Whenever one is down, my database will still be available. And it's also like distributed. It's on the edge, so it's really cool. You should check that. Now, the database that I have is Yugabyte demo. So I will run my engine on top of Yugabyte database. So let's get here, and what we will run Asura GraphQL database URL with Yugabyte demo, and this is the image that it will pull. So I will run that. Now it will take a bit of time to bring it up online. But now if we go to, meanwhile, while it's getting up, to create a Yugabyte cluster, you use create rf3, and for Asura specifically, you need to pass this flag. It's suppress unsupported. And in these examples, just to spare you like a bunch of typing, so I connected to a SQL shell, and inside I loaded sample data, which you can read in the docs how to do that. But the idea is basically I created database Yugabyte demo. I loaded a bunch of like products tables, users, orders, reviews. And right now I can basically, if I just run I think I have the shell here. Okay, let's leave this. So I can just run select count from product. I will have 200 products. But what I want to show you, if I go to localhost 8080 this time, I'll get to Asura console. And this time is a new console. It's existing. It's a new database, right? Like the existing database. And if I go to graphical, I don't see anything, but I see these tables and they are untracked. So I can click on track these tables, and then Asura will auto-generate GraphQL API for them. Let's go back and track also products. Let's also track reviews. And let's also track users. So now if I go to graphical tab, I can simply go here, get orders and products and reviews. Now, in order to get more meaningful results, I also need to map my foreign keys. So for the order specifically, I want to say that my user ID, add a foreign key, that my to reference the user table and saying user ID is referenced to an ID in the user table, and then to do the same for the product foreign key. Let's add another one. Take some time to set this up. And we add another one. It will be products table, and I will map between product ID to an ID on products table, right? Now, also what I need to do, remember the relationship tab we've seen with posts and users. I also need to set these relationships for both orders and products. And in fact, Asura will know that if there is a connection, like a foreign key set up, then it will suggest me the relationship that I want to have. So in our case here, it will be product, and it will be also user. Now, if I go to my graphical tab and I can get, for example, products with category, price, title, and vendor, and this is just getting products from this database, but I also can, I want to get orders, right? That's my mistake. I want to get orders, and let's say I want to get a user from orders, and it will have a name, and I want to know what the title of the product that user has ordered, and I want to know the price. And I actually don't remember what orders has, so I can go here and see what is the order type. It has total, it has user. Yeah, I just need total. And maybe I want to know the tax. So I run that. That's what I get here. Now, what I just ran, that's basically what it ran. Brings me to the joins that we've been talking about. Like you have left and right joins here. Like it creates the SQL query for you for yeah. So yeah, there are a bunch of questions. So how do you need to handle events failure on the client, or by posting event failures in the queue that can be reprocessed later on? So it depends on your implementation. Like you can do, if you use Asura or if you have your own server. If you have your own server, then you probably will handle this on the server. If you use something like Asura, then you can use it on the client. Or you can, whenever you try to write when you write into database, you can go through some kind of validation, which is you can do it asynchronously, basically writing inside the queue, or you can do it synchronously. I also wrote a blog post about how to do business logic and so on with Asura specifically. Another question, does Asura depend on particular database versions? For instance, can earlier Postgres versions still provide method access like schemas you've been showing? I'm not sure. Like, honestly, like I haven't, I know like in last year and a half, maybe 2 years, like all the versions last 2 years are supported, right? Like everything that was before that, probably, I don't know. Probably it's worth checking with the docs as well. Yeah. So I showed the sample data, and yeah, that's basically it. And I'm open for questions. If you have any questions on that, I would be more than happy to answer.
Yeah, so if you have any closing questions here for Vlad, feel free to ask them. We'll give it about a minute, and then we'll flip over to Nikol's presentation if there are no questions. So make sure to check out Vlad's blog, follow him on Twitter. He's got lots of great resources, lots of great information. Whether you're getting started or you're an advanced user of GraphQL, there's definitely something to learn.
The questions here, is this business logic blog post? No, this one is explaining what Asura is, basically. I have other blog posts on dev.to. So if you go to dev.to at Vladimir Novick, you will see a bunch of blog posts there. And the one I've been talking about is some of them here, this one. And Jimmy, where should I share these links, or we'll share later on with attendees?
The best thing to do is just email me or chat me the best links, and we'll include them in the follow-up email. That way, if they search, they can just click on them.
Okay, sounds good. So yeah, I have a bunch of content also. I put stuff on YouTube, and I stream on Twitch. So I will share links with Jimmy, and you will get all the links and so on. And yeah, just make sure to follow me on Twitter, because I post things constantly on like different updates, workshops, courses, free stuff, and so on.